Hi, welcome to Mesh to Nurbs, Part 7 Extras, and in this video I'm going to quickly cover a few points which I didn't manage to fit in the main presentation. So we see here that we've got the theoretical side glass, we've got the original projection curve with direct history alive on this side glass, and here we've got part of the blend. This is actually the cant rail. It's a freeform blend and it also has direct history. So let's take the move hull NUV, and I want you to notice that this cant rail is actually above the mesh. I'm using two shaders instead of the deviation map because a lot of my students have quite small computers and they can't really use the deviation map unless you've got quite a powerful computer. And also I'll show you another trick you can use if you are working on a laptop or a domestic computer. So for a start, you can come up here to history and you can suspend rebuilds. Now if I pick this and I bring it down, I'm moving the side glass down, but actually nothing is happening. But I'm not using a lot of processor power. And then I come over and my computer isn't kind of giving me that egg timer that sits there for 30 seconds, a minute at a time on a slow processor. So come back here and uncheck suspend rebuilds, and you'll see that the surface has updated, and we're starting to see this kind of frosty effect, like crystallized ice on glass, which you get when the two surfaces are very, very close together within, say, a couple of hundredths of a millimeter. So there you are, that's perfect there. And I could move just one CV here with NUV to work on this end of the surface. And as you see, it starts to improve. So those two surfaces there are actually very close. And as you can see now, that this is with a standard 1 mil acceptable distance. We know it's working the shader. This is with the deviation map because we have this blue here and blue there, but you see that generally it's a perfect fit to the mesh. So there's just a little tip on how to use live history, and when you're not exactly sure where the point of tangency is going to be, you can use a curve and you can alter that point dynamically. It will update with the direct history. Next thing I want to show you is how to dynamically model the C-pillar using the direct history on the theoretical side glass and on the freeform blend. So what we're going to do is, here's the original projection curve. I'm going to take NUV move. You'll see this area here where we're slightly below the mesh. If we bring the side glass up, then this cant rail C-pillar will rebuild and bring us into the mesh like so, and we can go along here and we can model each CV, or we can go to pick hull and we can model the entire hull. So you see the side glass is getting smaller and it's changing the fit of the freeform blend to the mesh. So there we are, that's that point covered. The next point I want to mention about this is that if you have you're working on a small computer at home, a laptop or a small PC, you won't be able to use the deviation map shader unless it's on a very, very small surface, because it needs a lot of processor and memory. So a way around that is to, and one other point on that, the subject of well, two things. First of all, that the shader drops out and you have to keep resetting it, which is very time consuming. And the other thing is that it does need a lot of processor. So let's look at an alternative, and I'm going to use quality shade, although you can just as easily use fast shade. When you're doing this, you should remember that you do need to be in perspective mode because the shaders don't work properly if you're in orthographic. So you get a different type of feedback, but for example, if you get this kind of these squares, kind of breaking up squares, or this kind of effect of like frost on a window pane, this means the surfaces are incredibly close in world space, and where we had that little deviation, you see it's not the case. It's kind of a solid tone, and there was a deviation there, and this kind of solid tone there as well. So we will just check that with the deviation map. And you'll see that we are within 0.9 of the mesh, apart from that little defect there. It could well be a mesh defect. And here there's some work to be done. Okay, next thing I want to show you is, this is the cant rail and this is the C-pillar. And this is a common area where finding alignment is very problematical, especially when you're working to Category 5 tolerances. So I'm going to talk to you a little bit about that. Now this is a typical scenario where I've aligned the cant rail to the rear screen theoretical, and in doing so it's thrown out the scaling of these tangent and curvature G2 hulls, and they don't match the cant rail anymore. So I've got curvature there, but when I curve snap them here to get position, then I'm going to throw out the curvature there most probably. So let me show you how to do that. Go into the Align tool, and you can re-invoke it if you've got it closed, and bring up this alignment again here, and then you need to uncheck that box there. You see where it says starting tangent scale, etc. Uncheck that, and then that lights up the curvature scale, and we're going to pick that little arrow there, and then using the nudge keys we're going to nudge the curvature CV hull until it aligns with its sister on the opposing surface. You see that we're quite close there. I'm going to go a little bit more until we've got it aligned. Yeah, that's it. And then you need to do, well, I've already done it, something similar on the tangent row, and then we're going to snap these together. Now most of you of course know how to do that, but just in case you don't, I'm going to show you very quickly. So what we do is need to pick the surface, and Alt D on my keyboard is to kill the direct history, and then we're going to use XYZ, move CV XYZ, and this is very important, which CV you pick first. So we're going to pick the bottom, so this is how I remember it so I don't get confused. Pick the bottom CV, which is the one for the cant rail, and then push down the control key and pick the top CV, and go along bottom CV, top CV. Well, it sounds very kind of childlike way of working, but nevertheless, it makes life a lot easier if you have these little kind of systems get everything done. Okay, so that gives us the position. Then the next thing we need to do, of course, is to model for tangency. So pick nothing, pick the locator, and then open the information window. And then in the information window we're asking for tangency, that's correct, and put on these. And if they don't show up, then you need to increase the scale factor for the comb there. So I'm going to increase it to, let's say, 50, so that we can see it. And we're ready to start. So now we take move CV, and sensitivity I've got typed in here as 1000 mouse sensitivity, and I'm going to probably just have to move one CV to get the tangency. See that the mouse is very, very sensitive, too sensitive in fact. I'm going to put it to 100. We're going in the right direction, and don't be tempted to do it all on one CV. I keep saying that, I know, but it's very, very important. if I had more time, I'd align these CVs with the align tool. Now I'm going to go for curvature, so I bring back my information window. I need to pick the locator, and this time we're going to ask for curvature. And there you are. We noticed from video 7.0 that we had an imperfection in the roof to theoretical front screen blend, and I just want to talk very briefly about that. I've got the visual curves on here, which is in the ISO angle shader, and you can see here that something's not right there. So we made this a degree 6 blend so that we would have that spare CV row there, and you can see how drastically I can modify the flow of highlights with that. Also I can come here and I can take the end one as well. So I think that looks already starting to look a lot better, because it's difficult to improve the flow and stay within the mesh, and if you wander away from the mesh, then you've got to go and get the designer and get their approval of the way that you've changed the surface. And here you see we've got a dip, so it's probably that CV there. Okay, so there's a little bit of information on how to manipulate highlights. I think it'd be quite a good idea to look at that with the double horizon shader on, and you see it's quite a lot better, isn't it? It looks as though the roof has got to be slightly flatter actually to get a perfect blend. Here it's perfect. That's what I would describe as G4 curvature. And here, in the middle there, you know, there is a problem. Well, you know, whilst we're here, let's quickly look at the roof, pick the roof surface. And so by moving the and I can see that the roof is slightly too flat here, and if we have a look at the CVs, you can see that this CV is too low. So let's just bring that up. You can see how it's affecting the flow of that there, and then we're going to pick that CV, this CV here. You can see we're out of curvature, so I'm going to use proportional modification there and there, and of course very important to have your symmetrical modelling on, and then I'll just model that back into curvature, and I'll do the same on that. So proportional modification again to re-establish curvature. Have a look at the flow of those there, and there's the final result, which is a lot better. Well, I hope that you found this video on extras interesting. These are the sort of things that I don't have time to include in the main teaching videos, because the videos would just be too long and tedious. And thank you very much for taking time to watch my video. Bye.